Hi, wherever you are in the world. My name is Farhana, but you can call me Far. I'm the CEO of Farbeat Solutions. Uh, Currently, we have two interns coming in, and they have served us for 2 weeks. And every week, they need to submit a weekly video report and what's in the box weekly update. So, for internship, we are quite different, and the way we work is quite different. We like to humanize work, so hope you enjoy the videos.
Hi, my name is Prassant, son of Mahendran, and I'm a third year student in UPM, currently taking Computer and Communication Systems Engineering. So during my first day in intern, we were supervised by Miss Money, and our first task of the day was to identify the brain of the system. So we were given a lot of electrical components to choose from, and we identified two types of brain of the system, and I chose PIC 16F877A as my brain of the system. This is a microcontroller which is very useful in remote sensors, home security, and safety devices. So I have made a very short slide about this microcontroller, about its pin assignments, all its features, and the details about how to use in projects. So stay tuned. So the task given to us is identify the brain of the system. The brain, which is a PIC 16F877A, is shown in the image below. So as you can see, this microcontroller is already soldered with the breadboard. So all we have to do is just assign the input and the output pins. Okay. So brief description about this PIC microcontroller 16F877A is it's a very renowned microcontroller in the industry, and it's very convenient and easy to use in terms of coding and programming. It also uses a flash memory technique, which is a write erase technique that causes the data transmission between components is much more faster. And this type of control finds its application in a huge number of devices, ranging from remote sensors, safety devices, security devices, and home automation. This gives me an insight on the field of project that I want to choose. Maybe I will choose from a field of security and home automation. And the cost of this controller is also very low, and the handling is also very easy. As you can see, there's a 40 pin instruction set. So each pin has an own function. So you just have to assign the pin to the correct outputs. And this microcontroller has an operating voltage between 4.2 volts and 5.5 volts. If the voltage supplied is more than 5.5 volts, it can damage the microcontroller permanently. Unlike PIC 18F46K22, it does not have an internal oscillator. So the maximum current for each port in this microcontroller is around 100 milliampere, and for each GPIO pin is 10 milliampere. Okay, next we will move to the pin assignments. So next we will continue with the pin assignments. As you can see in this diagram, there are 40 types of pin, and each pin have a different function. So the assign of the input output pin must be done precisely to avoid any errors. Okay, so I just picked some of the most important pin that we should know before we make use of it in our project. Okay, pin 1 is MCLR. This is the first pin in a microcontroller, and it's the master pin in this IC PIC. It resets the microcontroller. So the pin number 2 is RA0 AN0, which is the analog to digital converter. Pin 6 is RA0 TOCKI. This pin can act as the clock input pin. The type of output is open drain. So pin 11 and 32, this is the VDD pin, which is the positive supply of the input and output and logic pins. So both of them must be connected to 5 volts. Pin 12 and 31 is the VSS. These are the ground reference pin for input and output, and also the logic pins. They should all be connected to the zero potential, which is also known as a ground. The main features of this microcontroller PIC 16F877A is it has an analog to digital converter module, which is we call as ADC. In this microcontroller, it has 8-bit module which consists of 8 channels. That means we can connect it to 8 analog sensors. Just imagine what happens if it has a 16-bit ADC. That means we can connect to 16 more sensors with this microcontroller. So besides, it also has a timer, which is timer 0, 1 and 2. All these timer can be used to generate delays, pulse width modulation, counting external events and time interrupts. Besides, it also has a EEPROM, which is a electrically built-in erasable memory in the form of 256 times 8 bytes. So this EEPROM functions to store data permanently even if the microcontroller is switched off in an emergency situation. So usually this will be beneficial to us when we use it in projects with electronic locks. Besides, it also has a sleep mode, which is associated with a watchdog timer. Sleep mode provides a sleep mode operation, which the device will operate at a very low power, and all the peripherals are drawn to a minimum amount of current. So the watchdog timer functions to wake up the device from sleep mode, and it's also used to generate the watchdog timer reset. So that's all for our what's in the box assignment. And on the next week, which will be we will be choosing the type of programming language that we are going to use in our project. Thank you.